This is our next PPT for topic's name is physical properties of the cement. This is the learning objective. We had seen course outcomes. Hydration of cement. The silicates and aluminates of cement reacts with water. These reactions becomes a binding medium. This called hydration, and this process generates heat is called heat of hydration. This process is called exothermic process. Due to it, produce heat near about 120 calories per gram. More the mass of concreting, more the heat generated. The temperature and the fineness of cement is mainly affecting the heat of hydration. So, hydration of cement is basically the reaction between the silicates and aluminate material to the water. Physical properties of the cement. Let's see, there are different physical properties of the cement. The first one is the fineness. The fineness is nothing but the fineness of cement is measure of the size of particles of cement. It is expressed in percentage written on the 90 micron sieve. Reactions and early setting time of cement is mostly affected by fineness of cement. Second property is setting time. The time taken by the cement slurry to get hardened mass. There are classified by initial setting time and the final setting time. Initial setting time means the time taken since water is added into the cement up to the initial setting of the concrete. It will be the 10 minutes for the ordinary Portland cement. So, the initial setting time of the cement is 10 minutes for the ordinary Portland cement. The final setting time, the time taken to green cement to harden mass. Green cement means fresh concrete to harden mass. It will be the 600 minutes for OPC. So the final setting time is 600 minutes for OPC. Next property is the strength. It is the most important strength. It is the capacity of concrete or cement to take load. It's called compressive strength of cement. Compressive strength determined by compressive testing machine. So compressive strength of the cement is determined by the compressive testing machine. Cement are weak in a tension. Strength are measured in Newton per mm square. So basically the compressive strength of the cement is determined by the compressive testing machine and is measured in Newton per mm square. Cement are weak in a tension. The next property is soundness. Soundness is nothing but cement is increase the volume after hardening. But if the quantity of free lime and magnesia is excessive, then the cement is unsound after hardening. The free lime and the water get mixed. It produces some compound. So this compound should be present within permissible limit. The soundness of the cement is increasing the volume of cement after hardening. The next property is the heat of hydration. A very important property. The chemical reaction between cement and the water is called hydration and it produces heat. It, the heat of hydration depends upon the fineness and the temperature. Now, the grade of cement. There are different type of the grades present in the cement. The ordinary Portland cement is divided into three grades, namely 33 grade, 43 grade and the 53 grade, depending upon the strength of cement at 28 days when tested as per IS 4031-1988. Look at the 33 grade cement. The strength is not less than 33 Newton per mm square at 28 days. If we tested the 1 cube of cement in 28 days, its strength is not less than 33 Newton per mm square. It's called 33 grade cement. It is a very high workability in 33 grade of cement, and its uses for normally masonry work and the plastering work. Second one is 43 grade cement. The strength is not less than 43 Newton per mm square at 28 days. It means that if we cube tested in 28 days of cement, the strength is not less than 43 Newton per mm square at a 28 days. It's called 43 grade cement. Its property is moderately sulfate resistance and has a low chloride content. And its uses, it is used in a precast and prestressed concrete, ready-mix concrete, PCC, it means plain cement concrete, and RCC, reinforced cement concrete work, and in RCC bridge. The next is 53 grade cement. The strength is not less than 53 Newton per mm square at 28 days. So if we tested the 1 cube of cement in a 28 days, the strength is not less than 43 Newton per mm square. So it's called 53 grade cement. Its property is moderate sulfate resisting and also has a low chloride content. Its uses is this cement used in pre-stressed girders, concrete sleepers in railway industrial buildings, roads and the railways. Now see the physical characteristic requirement of OPC as per the IS standard codes. So there is a characteristic and the requirements. It is a 33 grade, 43 grade and a 53 grade. It is the characteristics. First one is minimum compressive strength in Newton per mm square. Within the 3 days, 33 grade of cement achieve 16 Newton per mm square strength. In 7 days, 22 Newton per mm square strength, and in 28 days it becomes the 33 Newton per mm square. Now look at the 43 grade cement. In 3 days it achieved 23 Newton per mm square compressive strength. In 7 days it will become 33 Newton per mm square compressive strength, and in 28 days it will become 43 Newton per mm square. Now look at 53 grade cement. Within 3 days it achieved 27 Newton per mm square compressive strength. In within 7 days it will achieve 37 Newton per mm square, and in 28 days it will achieve 53 Newton per mm square. It is a minimum compressive strength within 3 days, 7 days, 28 days. The second property is fineness. Fineness of all 3 grade cement. Fineness of 33 grade of cement is 300. Now 43 grade of cement fineness is 225, and 53 grade cement's fineness is 225. Okay. The next property, next character is setting time. Initial setting time and the final setting time. So the initial setting time of 33 grade cement is 30 minutes and the final setting time is 600 minutes. So it is both same for all grade of cement. The last property is soundness. It means expansions by Lee Chatelier method. It is a method to find out the soundness of cement. So it is 33 grade for 10 and 0.80. It will also same for 33 all grade of cement. Now the testing of Portland cement. So testing is purposely the properties and qualities of Portland cement determined by testing of cement before its use. The testing of cement is by field test and the laboratory test. There are two methods of testing. Field test means testing of cement on the site, and the laboratory testing means testing of cement in the laboratory. In the laboratory, there are three major tests which were conducted. The first is fineness test to find out the fineness of cement, standard consistency test to find out the consistency of cement. The last one is compressive strength test to check the compressive strength of the cement. Field test, the testing of cement on the site. There should not be any visible lumps after the open cement bag. Should not feel oily when touch the cement. Cement should be greenish gray in a color. If we thrust the hand into the cement bag, it must give cool feeling to our hand. Take a pinch of cement, it gives a smooth feeling to a finger. The handful of cement throw on a bucket full of water, the particle should float for some time. All this, if a sample of cement satisfies the above field test, it may be concluded that the cement is not bad. So, all these field tests conducted on the field on the cement to verify the properties to verify the cement it is usable or not. Now, laboratory test, and the first test is fineness test. Fineness influence to the rate of hydration, the rate of gain strength, and the rate of evaluation of heat. So fineness of cement is the most important physical characteristic which directly influence on the rate of hydration and the strength and the evaluation of heat. The greater surface area of the hydration due to the fineness. If the more the fineness of cement, the greater surface area for the hydration and the greater the heat generated. The different cement have different fineness. So different grade of or different cement have a different fineness. So fineness are tested by sieve method and by air permeability method. There are two methods to find out the fineness of cement. These are sieve method and the air permeability method. Fineness testing by the sieve method. It is the first method to find the fineness. The main aim of this test is to check proper grinding of cement. Fineness means grinding of the cement. So steps involve, first step is take a 100 gram of sample is taken and place at standard sieve number 9. It means 90 micron. All lumps in the samples are broken. Then sieving is done continuously for 15 minutes. Cement written on the sieve is weighed. The weighted should not exceed 10% of the OPC. If we are taking the 100 gram of sample, the weight should not exceed 10 gram of OPC. Fineness testing by air permeability method. Aim of this method is the aim to determine the fineness or surface area per gram of cement. This is the diagram of air permeability method. It is the plunger right side of the corner, then permeability cell, and it is the manometer. Principle of this method. The fineness of cement is measured as specific surface. Specific surface is expressed as the total surface area in a square meter of all the cement particles in 1 kilogram of cement. The higher the specific surface is, the higher finer cement will be. Okay, if the higher the specific surface and the fineness of cement is also more. This is the Blaine air permeability apparatus picture. Procedure of air permeability method. Firstly, put a filter paper into the cell, then weight 2.84 gram of cement sample into it. Then put another filter paper on it and compress the plunger. After the putting of wet sample, put the plunger. Attach the cell on top of the U-tube manometer. Evacuate the air in the manometer through the side tube using the aspirator bulb until the oil reaches level 1. Close the side valve and monitor the oil as it starts to fall. Using a stopwatch, measure the time taken for the oil to fall from level 2 to level 3. It is the formula for find out the air permeability by Blaine method. It is K under root of T, where K is the 523.015. It is a constant, and if take example when T is obtained a 929 second. If we time consider for 29 seconds, then K is a constant, so it will be S is equal to 523.05 under root of 29. So the air permeability will be 2817 cm square per gram. Now standard consistency test. To determine the quantity of water required to produce a cement paste of standard consistency. So standard consistency test especially to find out the water requirement to produce a cement paste of a standard consistency. So there are using the Vickett apparatus we should find. This is the Vickett apparatus and its component. Principle of this method is the standard consistency of cement paste is defined as the consistency which will permit the Vickett plunger to penetrate 2.5 to 7 mm from the bottom of the Vickett mold. So this is the main principle, and the apparatus required for this test is Vickett apparatus and the balance. This is the picture of Vickett apparatus. Procedure is the weight approximately 400 gram of cement and mix it with a weight quantity of water. The time of judging should be between 3 to 5 times. Fill the Vickett mold with paste and level it with the trowel. Lower the plunger gently till it touches the cement surface. Release the plunger, allowing it to sink into the paste. Note the reading on the judge. Repeat the above procedure, taking fresh samples of cement and different quantities of water until the reading on the judge is 5 to 7 mm. And the result is express the amount of water as a percentage of a weight of dry cement to the first place of decimal. How much water is required for consistency? Next is compressive strength test. The aim is determine the compressive strength of cement. The apparatus required for this test is compressive strength testing machine cube molds, and the poking rods. This is the compressive strength testing machine to find out the compressive strength of the cement and the concrete. Procedure of cement procedure of compressive testing. Look at days is equal to 7 and 28 days. The test is conducted for 7 days and the 20th day sample. Temperature requirement should be 27 degrees Celsius plus minus 2 degrees Celsius as per the IS code. Prepare the cube of cement and sand. So only cement we should not test it so that sand will be added in the cement and make a cube. These cubes are kept in water for respective days. For 7 days testing, it will be for 7 days, and for 20th days testing, the cement cubes are kept for 28 days. After the 28 days, cubes are removed from the water for testing. These cubes are placed in compressive strength testing machine, and then down the pressures apply on the cubes from pressure gauge into cube up to the cube gets cracked. This load can be calculated. The calculation of compressive strength will be load upon cross-sectional area of the cube or specimen. The compressive strength in a Newton per mm square. Thank you.